Immunocytochemistry has been the technique of choice to map novel neurotransmitter substances, receptor localization, and neuroanatomical pathways. Impressive progress has been made with its coupling with image technologies and computer analysis. However, until recently, immunocytochemistry relied on tissue sectioning, sometimes followed by serial brain tissue section reconstruction. These approaches are long and yield incomplete spatial distribution. If confocal microscopy and 2 or 3 photon imaging technologies have improved the detection of fluorescence, immunostaining, and cell counting on sections, such methodologies are still limited by the sample size and by light scattering through sick tissues. New methods of clearing samples to achieve transparency of intact tissues have emerged recently to avoid such phenomenon, particularly light scattering. Such approaches as 3-DISCO or iDISCO Plus have been carried out on various tissues. In conjunction with in toto immunocytochemistry and light sheet imaging, these techniques allowed successful three-dimensional reconstitution and visualization without brain cutting. In this paper, carried out at the Vision Institute in Paris with my colleagues who took part of the development of the technique, we first used the well-known distribution of tyrosine hydroxylase in order to set up the technique. We thus validated with tyrosine hydroxylase the iDISCO technique with clearing and high-resolution ultramicroscopic imaging on postnatal P5 mouse brain. Postnatal P5 was chosen because several neurotransmitters and neuropeptides are still developing at that age in the brain and allowed to make a study of the developmental pattern of these neurotransmitters. Then we focus on 2 important known neuropeptides, oxytocin and vasopressin, in the mouse hypothalamus. In fact, we demonstrated that oxytocin neurons are still developing in the paraventricular nucleus, for instance, whereas vasopressin neurons, less numerous at that age, already reach maturation with neuroid processes. But no word can replace the video. So have a nice short trip with oxytocin in the 3-dimensional mouse hypothalamus. Just to conclude, a take-home message with 2 technical points. First, you need the adequate equipment to do such studies. An ultramicroscope using a live sheet generated by laser and a good software for image segmentation and 3-dimensional reconstitution. 2, various primary antibodies have been carefully tested, since some of the antibodies which work on thin section may not support the rapid transpirization process. So I hope you enjoy this trip in the brain. How these images have been made and obtained is described in the paper published in the December issue of Journal of Neuroendocrinology. And now, it's your turn to make wonderful images related to your favorite neuroendocrine subject. And good luck!